This is the MyHeart.net podcast. This show is produced by Dr. Philip Johnson in conjunction with VitalEngine.com. Please welcome your host, Dr. Alain Bouchard, a cardiology specialist of Birmingham, Alabama, at St. Vincent's Medical Center, part of Ascension.
So welcome to our podcast. And today we're going to talk about the HDL cholesterol conundrum. With us, we have a very special guest, Professor John Kastelein. He's an emeritus professor of medicine in the Department of Vascular Medicine at the University of Amsterdam, and is chief medical officer at New Amsterdam Pharma, in the Netherlands. And John, I want to appreciate you taking the time and maybe shedding some light on this mystery of HDL cholesterol.
Thank you, Alain. I'm honored to be here with you.
Very good. So let's talk about HDL, cholesterol, because it's such an important cholesterol lipoprotein because it's the good cholesterol. It seems like the more you have, the better it is. And when we want to calculate the atherosclerotic risk, over the next 10 years, you always factor in the total cholesterol and the HDL. And of course, when your HDL is in the order of like 80 or 90, it seems like the chance of getting a coronary event in the next 10 years is very low. It's very protective. Yeah. We know also that if you have very little HDL, and if you're a patient with abdominal obesity, the so-called metabolic syndrome, you have low HDL, you have high triglyceride, you're hypertensive, you're pre-diabetic, and your risk of getting a coronary event is quite high. Yes. So when you have a low HDL, it's usually you're at increased risk unless you're fortunate enough to be part of this family in northern Italy, where they're blessed with the ApoA1 Milano, and they get to live to 100. But that's just about maybe 3 dozen, in Solgarda in Italy. So can you tell us a little bit more? What is the HDL cholesterol, and what is the function of HDL?
So your introduction was absolutely perfect. Epidemiologically, high HDL is the strongest independent protector against heart disease, and low HDL the strongest independent risk factor for heart disease. And for example, when you want to enrich your trial population for high risk, you take low HDL people. Then you're going to get a high event rate and everything. Those two things made everyone believe that raising HDL would be fantastic, that would be a good thing. The thing we forgot at that time is that if we raise HDL, we just raise HDL cholesterol. And it was proven, and this was thanks to a CETP inhibitor trial called DAL Outcomes, where HDL cholesterol was raised by 40%, that it actually didn't do anything to heart attacks or strokes. So we now understand that. But HDL cholesterol, or HDL, when you measure that in an individual, it is becoming more and more likely that that's a reflection of good cardiovascular health. So it represents a lot of things. It represents, as you were saying, central obesity. It also represents, are you smoking or not? There are a gazillion, and then there's genetics into it. So there are a gazillion things determining your HDL, and the things that lead to a high HDL are usually associated with less athero, and a low HDL associated with more athero. Now, I was part of a team at the University of British Columbia a long time ago that cloned the ABCA1 gene with Michael Hayden. That gene actually is coding for a protein that is called the cholesterol pump. That cholesterol pump is present on many membranes of many cells, and important cells, macrophages, beta cells in your pancreas, on all sorts of immune cells. It's present in your brain in important cells in cholesterol metabolism, and it's also in your eye. And so that pump that sits on the outside of cells interacts with the major protein of HDL called ApoA1. ApoB is the B from bad, and the ApoA is the A from, and I don't know, I've never found a word that could go with that, but that's a good protein. When ApoA in HDL, small HDL, interacts with ABCA1, it sucks cholesterol out of cells. And it's important to remember that as a human being, we cannot break down cholesterol. We don't have the machinery for that. Fungi can do it, but we can't. So we have to physically remove cholesterol. And HDL is very important for that, but not for heart attacks and strokes. But for example, very important for diabetes. There is more and more evidence that if you have type 2 diabetes and you convert from non-insulin dependent to insulin dependent, that is because your beta cells are dying. And they die because of lipotoxicity. There is sterols and oxysterols accumulating in the beta cell, and then the beta cell at a certain point in time gives up, can no longer produce insulin. And if you have a very active HDL system that can suck cholesterol out of beta cells, your beta cells are going to live longer. And it's very interesting. We just wrote a meta-analysis of all CETP inhibitors, and they have 16 to 20% less new onset diabetes than the placebo. And so that is because CETP inhibition produces a small HDL particle that's very active in the beta cell. We also think in the brain and in the eye, by the way. Then there are extremely interesting data on HDL and septicemia. If you have sepsis and your HDL is high and you can keep it high, your chances of dying are like 3 to 4 times less than when your HDL nosedives when you have bacteremia. So it's clear that evolution has given us the HDL system not only to protect against excess sterol or excess cholesterol in cells, but also kind of as an absorption agent for endotoxins and bacteria. So HDL is much more than we originally thought. It is something that protects us against a heart attack, and if you raise it, it's easy, you'll get less heart attacks. So it's much more complex. Now, that is kind of the biology where we currently are. The epidemiology, unfortunately, in the last 2 or 3 years, has reinvented this J-shaped curve between HDL and, for example, all-cause mortality. We knew about this like 30 years ago, and it's interesting, I'm long enough, and you too, we're long enough in this business to know sometimes that things have been invented 30 years ago and reinvented now. Now, one of the things you cannot study in an epidemiological study is elevated HDL cholesterol. And why can't you do that? Because alcohol abuse will raise HDL. Some agricultural toxins will raise HDL. And there are many things that you can do that will raise HDL that have a risk for other diseases. And what is linked in biology, you cannot dissociate with epidemiology. So all these studies that are now published are hopelessly confounded, with residual bias. And as fast as they appear in a journal, the faster I throw them in my waste bin. It's honestly so strange that a thing that is considered so good and is a reflection of good health, when it's in the very high regions, which by the way are only very few people, that you see all-cause mortality go, that is because these people have other things that lead to an increase in all-cause mortality. So we shouldn't let ourselves be distracted here. HDL is a fantastic particle that has multiple functions in our body that are all good for us. But we shouldn't be pediatric in our thinking and thinking that if we have like nicotinic acid or a fibrate, raise HDL by 20%, that's going to help us with heart attacks and strokes, because it isn't. So that is where we are currently.
Very, very. So you mentioned so many important points, John, but it seems like it's more than just the number of HDL that really counts. And unfortunately, that's all we measure in clinical practice, but it's the function of HDL that is so crucial, and that function, not only it serves like, I guess, HDL particle can be like a garbage truck, taking all these bad cholesterol, LDL, out of the system, and
the toxins also.
Yeah, exactly right.
Also
but it's
scavenge and the toxins.
Yeah, and it works against inflammation. So there's a lot of function. Are we able to measure function of HDL in clinical practice, John?
Yes. So it's interesting. Dan Rader is the true pioneer here, of course. He published a number of very important papers on cholesterol efflux. He linked less efflux with more heart disease, more abnormalities on the coronary angiogram. His assay is a cell-based assay, and therefore it is wonderful for studies and in the lab and in academia, but it's not really. So what we need is a high throughput assay, something that will not be necessary on a cell, but on an in vitro testing system. And I know that NIH is working on that. Yeah. So hopefully we will get soon this efflux test in a more amenable kind of version. Right. Ellen, I wanted to add something that most people don't appreciate about HDL. So we talked about CETP inhibitors on another occasion, and it's always said very easily in the literature is that the HDL increase conferred by CETP gives you a constipated HDL or a dysfunctional HDL. So what we did is we took the REVEAL database, that is anacetrapib, the Merck CETP inhibitor, that was tested in 30,000 patients. That's the largest CVOT ever. That drug raised HDL by 100%. So if HDL raising would be dangerous, that trial would have told us that it's dangerous. So we took that delta HDL, then we related it to all the side effects from the MEDRA basket. The MEDRA terms give all the side. There was no association with that 100% increase and any safety. Interestingly, and this we are further exploring this, it seems there is a relationship with all-cause mortality, a beneficial relationship, which was also seen with the Eli Lilly trial, where in fact all-cause mortality was down on the Lilly CETP inhibitor with a P of 0.4. And so there is something that makes me think that when you raise HDL to that magnitude, there are other effects. Maybe it's the anti-diabetes effect or the anti-Alzheimer effect that contribute, if you make the trial large enough, to mortality in some other way. And I'm scientifically, that is currently what I'm working on the hardest, to understand that. Yeah.
Well, you did mention, some of the ways that we have to increase HDL. A lot of times, exercise, will help, increase HDL and will lower, mortality. The effect is modest. We've tried niacin. It raised HDL somewhat moderately, but then had no effect on outcome. No. And it seems like, some of the best ways that we have may be coming up in the future. And you did mention, obviously, the advance in the development of the CETP inhibitor. You're working with this new CETP inhibitor, relatively new, I would say, certainly with some new application, obicetrapib, at New Amsterdam Pharma. You did a trial that was, so much from Amsterdam. It was called your phase 2 TULIP, trial, which was, a study over 300 patients. What was very interesting to me, of course, in that study, you did measure not only the HDL. I mean, the HDL was increased by almost 150%. You had people walking around with HDL all above 100, milligram per deciliter. And also you measured the efflux, which is really one of the function of HDL. It seems kind of so promising. And as you said, not so much by the fact that the HDL was high, but maybe by some of the effect of elevating the HDL on other targets like the diabetes.
It's interesting is that what we now have also understood, which was never understood well before, is that the inhibition of CETP leads to the production of more HDL. So this is not just inhibiting the transformation of HDL or the metabolism. No, it's increasing production, and it does that by increasing ApoA1, the good apolipoprotein production, by 65%. So it's by far the most efficacious way of raising ApoA1 in the circulation. And as you know, ApoA1 comes out of the liver in a tiny HDL particle called pre-beta HDL. And in TULIP, we measured that too. And the increase there was like 80% of that small pre-beta HDL. And efflux was increased by about 30 to 40%. Now, as you know, there's a very important company called CSL Behring that have recreated an HDL particle, I think in my mind, very effectively. And they are now testing the infusion of that particle, which is mimicking the liver producing it, in a very large trial called AEGIS-II. And that trial is now fully enrolled. That's public knowledge. And so we'll have to wait for the outcomes. But it's extremely interesting is that if that trial is positive, the whole HDL hypothesis will be revived, but not in the old-fashioned way, raising HDL cholesterol with nicotinic acid, as you said, or fibrates. No, by actually mimicking the liver producing small functional pre-beta HDLs. So who knows, maybe, this whole thing will be turned on its head when the AEGIS-II trial will read out, which also will confirm that the HDL particle that you get by inhibiting CETP is also a particle that actually can be functional and actually beneficial for a number of diseases. Yeah.
Finally, solving the HDL conundrum?
That might well be that you shouldn't work on HDL cholesterol at all, that has nothing, but that you should work on the production of small functional HDL particles. Yeah, could be.
Well, thank you very much, John. I think that was very, very interesting, and maybe kind of giving us a new perspective on the HDL. There's more than meets the eye. John Kastelein from the Netherlands, professor of medicine at the emeritus professor of medicine at the University of Amsterdam. Thank you very much for your time. Really enjoyed this conversation.
I enjoyed it too, and I thank you very much for this wonderful time.
To learn more from our team of cardiologists, please visit us at MyHeart.net. You can also follow us on social media by searching MyHeart.net on Facebook and Twitter. And be sure to subscribe to this podcast so you don't miss our next episode.